In this video, let's try to understand the concept of limits. Limits form the fundamental concept of entire calculus, and really the entire calculus is based on this concept. So to start with, let me take a function. So let's take a very simple function to start with. Let's say I have a function of x, which is x squared minus 4 over x minus 2. So let's say I have this function. Now to understand how the limits work, let's try to understand how this function behaves at different values of x. So let's say I take x equals 1. So let's start with x equals 1. So I have f of, so let's plug in 1. So if I plug in 1, I get 1 squared minus 4 over 1 minus 2. And you can do the math over here and the value comes out to be 3. Let's try some other values. So let's say I have 1.9. So let's try to plug in 1.9 in that function. So I have 1.9 squared minus 4 divided by 1.9 minus 2. And if I do the math over here, this value will come out to be 3.9. Let's take few other values so that we have what we need. 1.99, and we'll get 1.99 squared minus 4 over 1.99 minus 2, and by doing the math over here, 3.99. Let's take few other values on the right hand side. uh, let's take 3. So I have 3 squared minus 4 over 3 minus 2, and this value comes out to be 5. Let's say I have 2.01. So let's say take 2.01. So on the right hand side I have 2.01 squared minus 4 over 2.01 minus 2, and this value will come out to be 4.01. And let's take the final one, which is 2.001. So you get 2.001 squared minus 2.001 minus 2, and by doing the math over here I get 4.001. Let's plug in those values over here. So I have 3, which is here for 1.9. For x equals 1.9 I had 3.9. I had 3.99 over here. For x equals 3 I had 5. 4.01. For x equals 2.01. For x equals 2.001 I had 4.001. Now something interesting happens at x equals 2. If you try to plug in x equals 2, let's see what happens. So you get, so plug in x equals 2 in this function. So you get 2 squared minus 4 over 2 minus 2, which is 4 minus 4 over 2 minus 2. This is nothing but 0 over 0. And 0 over 0, this type of a form in calculus, this is called as indeterminate form, and we cannot really solve this, and this type of forms are really not defined, so we call this as not defined. So basically at x equals 2 we cannot find the value of fx. That means that at x equal to the function is not defined. So do you notice one pattern over here? So one pattern is, as the values of x get closer and closer to 2, so as I have 1, 1.9, 1.99, as I'm getting closer and closer to 2, the value of this function gets closer and closer to 4. Oops. Okay, so as 3.99. Okay, so as my values of x get closer and closer to 2, my function of x gets closer and closer to 4. And we have a special notation in limits, we'll come to that. And you will see the same pattern even from the right hand side, as in when the value of x get closer and closer to 2, the value of fx get closer and closer to 4. Now what this means, so we notice that as x is approaching to, or in other words, x is getting closer and closer to 2, in limits we have a special notation for this. We call this as x is tending to 2. So this arrow is called as, is read as tending to, which means really approaching to 2. Fx approaches 4. But one really important thing over here, notice that x is getting closer and closer to 2, but it cannot really get equal to 2, because at x equal to 2, my function is not defined. So one thing very important to note here, that x can get really closer and closer to 2, but it cannot get equal to 2. And you can get like really closer to 2. I can plug in for x, I can plug in 1.9999, which will give you 3.9999, or in other words, you will get really close to 4. Okay, so we have a, as x is approaching 2, my function is approaching 4, and to put it mathematically in limits, it's represented as, I write limit x tending to 2. So I say as my x approaches to 2, and my function, so my function was x squared minus 4 over x minus 2. And as my x approaches to 2, this function x squared minus 4 upon x minus 2, this function approaches 4. So this is like a basic notation in limits. So limits is really nothing but finding the value of the function as the value of x or its input gets really close to a certain value. Okay, we could have solved this in a simple way. So let's say I need to evaluate limit x tending to 2, x squared minus 4 over x minus 2. So let's say we want to solve this. We know the answer of this limit, or the value of this limit, is nothing but 4, but let's try to solve it analytically. Okay, so we have limit x tending to 2. We know this 4 is nothing but 2 squared, so this 4 is nothing but 2 squared, and so this becomes x squared minus y squared, which is nothing but, we know x squared minus y squared is nothing but x minus of y times x plus of y. So we can break that, and this would be x minus 2 times x plus 2 over x minus 2. Okay, and we can really cancel out this term over here, x minus 2. Now you'd say, oh, but this value is nothing but not defined at x equal to. So if you put plug in, try to plug in x equals to, this becomes 0 over 0. But one thing to note is x is never going to be equal to 2. It can get really closer to 2, but it will never get equal to 2. So it's safe to cancel out this. If x was equal to 2, I just cannot cancel out 0 in the numerator and denominator. But since x is never going to get equal to 2, but it will only get close to 2, it's safe to cancel out this. So I write in the bracket over here that x is tending to 2, which means x is not equal to 2, and that is why it's safe to cancel out these terms. Okay, now let's see what I'm left with. Limit x tending to 2 of x plus 2, and this will become, and now it's really the matter of plugging in the value. So I have this x equal to 2, just plug in over here and you get 2 plus 2, which is 4. So you see, limits are nothing but just evaluating the function at a value of x, where the value of x get really close to certain value, and you're trying to evaluate that function for you are trying to evaluate that function as that value gets really close to certain value. Okay, that's all for this video. I hope you liked it. Please post your questions in the comment section below. Thank you.